Math 3, Unit 6, Section 8. Today we are going to continue our conversation about graphing radical equations, but specifically today we're going to be talking about cubed roots. Okay, so just like when we talked about our square roots, cube roots had the same ideas in terms of our translations and our key points. So we still have our same key point or starting point, and that on here our starting point was at 0 because nothing was being added with the x, and then 0 for the y because nothing's added at the end. So same thing here for our parent graph starting point. Nothing is here with the x being added or subtracted, so the x is 0, and then there's nothing added at the end, the y is 0. So again, our key point or starting point here, both of those are at 0, 0. So that also, they'll translate based on that information. And so if you're adding c at the end, it will be shifting up. Subtracting c would be shifting down. If you are adding with the x, that actually ends up making it shift left. And subtracting would be shifting it to the right. The negative in front reflects about the x-axis. The negative inside with it will reflect about the y-axis. Dilations, remember that they shrink or enlarge, and that is all based on having a value in front of your function, a constant a value will shrink or enlarge the function. Okay. Another thing to think about with cube roots is there is a form of symmetry, in that when you have a positive number under a root, you get a positive answer. And if you have a negative under a root, you get a negative answer. And so if you were to look here at these 2 points, if you end up having a point that's going like up one, right one, you will also have the same point, but it would be going down one, left one. And then you'll notice from your key point or starting point, it curves like up and right. And then from the key point, the other point, it's curving down and left. All right, so let's just go ahead and start our first example. And so here is the function that we're going to be graphing. And so our starting point or key point, there is nothing with the x under the root, and so that is 0. And then the y value is -1. So we're going to go ahead and plot that on here. So 0, -1. Now, hopefully you notice here that this is on the y-axis, and so I would probably go and write my y-intercept right now so that I don't do work that I don't have to do. And so my y-intercept is at 0, -1. Next, we're going to go and find our x-intercept. And again, we know that we are going to plug in 0 for y and solve for x. Okay, and so in this equation, we plug in 0 for y, so that means I have 0 equals the cubed root of x minus 1. And we want to try to get that root by itself, so I add 1 to both sides, and I have 1 equals the cubed root of x. In order to get rid of a cubed root, you have to cube both sides, so I cube both sides, and 1 cubed is 1, and when you cube the cube root, it just gives you x. And so my x-intercept for this equation is 1, 0. So 1, 0 is this point right here. So if you notice on here, this from my starting point here to that point, it went up 1, right 1. And so to get the other portion of the graph, we do negative, negative. So I'd go -1, left 1, and I would get this point. We also know that this one is going to curve up and over, and this one curves down and left. And so that is how my cube root function should look. Going back to domain and range, for all cubed root functions, because negatives are okay, your domain, if you look here, it starts at negative infinity and goes to positive infinity. Same thing for your range. Because of the arrows, it's starting at negative infinity and it will go all the way to positive infinity. So in cubed root functions, your domain and range are both negative infinity to positive infinity on both of them. Okay, the open interval where f is increasing. So you can check this out by going to the left and starting at the left side, and the whole graph is increasing. And so that's from negative infinity to positive infinity. The open interval where f is negative. So the open interval where f is negative is anything that's below the x-axis. So below the x-axis is negative. And so this part of the function from here to here, all the way to that, is negative. And so you always start from the left to the right when you are writing this information. And so the interval is negative, starting at negative infinity and going all the way to this point right here, which is at 1. Okay, and then we ask for the average rate of change on this interval right here. We know to find the average rate of change, you have to use the slope formula. Our slope formula is y2 minus y1 over x2 minus x1, which means we need 2 ordered pairs. Right now, I only have 2 x values. And so the x values I have are 0, and we need to find the y. And then the other x value that I have is 8, and I need to find the y. So we use our function from the very beginning, which is our y equals the cubed root of x minus 1. And so we're going to use that and plug in 0 for x and find y. And so we have y equals the cubed root of 0 minus 1. Okay? And so we know that the cubed root of 0 is 0, and 0 minus 1 is negative 1. So 0, negative 1. If you had noticed that we already had x is 0 up here, you didn't have to do all that work, but I didn't notice it. So we did the work and found that it's also negative 1. Okay, so we have one ordered pair. Now to get the other ordered pair, we're going to plug 8 into our equation. And so I have y equals the cubed root of 8 minus 1. 8 breaks down to 2, 2, and 2. So a group of 2's, because we need 3 for our group. And so we get 2 minus 1, and 2 minus 1 equals 1. So now we have our 2 ordered pairs, and so we find our average rate of change by subtracting the y's. So if I start here, we have 1 minus a negative 1. Okay, and then since I started with this one, I start with the 8, and I have 8 minus 0. Remember that 2 negatives side by side end up making a positive, and so I end up getting 1 plus 1, which is 2, and 8 minus 0 is 8, and 2 eighths reduces to 1 fourth. So my average rate of change is 1/4 from 0 to 8. All right, we're going to go ahead and move on to the next example. Okay, so again, the way that this function right now is written isn't the way that I like to look at it, and so I would rewrite this so that my root part is first with my x, and then the y value is at the end. And so I'm going to write this as g of x equals negative cubed root of x plus 1, and then I have this positive 2 here at the end. So based on this information, I know a couple things. First of all, I know that there's going to be a reflection because of that negative in front. Okay? So we're just going to have to see what happens with that. But I still will get my starting point or key point here. So for the x, we'd set that equal to 0. So that would be negative 1 for the x, and then 2 is being added at the end, so that's 2. So I'm going to go ahead and plot that. Negative 1, positive 2, and again, that is my key point. Even though there's a reflection for all cubed roots, because negatives give us real values, my domain and range is always going to be negative infinity to positive infinity. And you'll also be able to see this once you have the graph. For my x-intercept, I'm going to plug in 0 for y and solve for x. And so I'm going to use this equation that I rewrote and highlighted. We know that g of x is the same thing as writing y. And so I'm plugging in 0 for y and solving for x. So 0 equals negative cubed root of 0 plus 1 plus 2. And, oops, I don't know why I put another 0 there, sorry. That's supposed to be x. And we are solving for x, and so I'm going to subtract 2 to both sides. So now I have negative 2 equals negative cubed root of x plus 1. You can go ahead and get rid of the negative in front as well by dividing both sides by negative 1. And so 2 negatives make a positive here, 2 negatives make a positive here. And so I now have 2 equals the cubed root of x plus 1. In order to get rid of a cubed root, we have to cube both sides. So we're going to cube 2, and we're going to cube our cube root. And so I have 8 equals x plus 1. And to get x by itself, I subtract 1 to both sides. So 7 equals x. So my x-intercept is 7, 0. So I'm going to go ahead and go 1, 2, 3, 4, 5, 6, 7, 0, and make that point. And so on this one, again, if we are talking about how our curve should go, this went down 2 and right 1, 2, 3, 4, 5, 6, 7, 8. Okay, so down 2, right 8. So that means I would need to go up 2 and then left 8. 1, 2, 3, 4, 5, 6, 7, 8 to make that point. Okay, and the way, since this is going down here, this would be from these points, it would curve down and right like that, and this one curves up and left like that. And I'm sure you guys could draw those better. Okay, this time says the open interval where g is decreasing, and going left to right, the whole graph is decreasing. So that is negative infinity to positive infinity. The open interval where g is negative, so at this point right here and on, that's where it's negative. And so that point is at 1, 2, 3, 4, 5, 6, 7, right? Which would make sense, our x-intercept. And so it's negative from 7 to positive infinity. And then we forgot the y-intercept. We have an idea of where the y-intercept might be, but in order to find the exact y-intercept, we plug in 0 for x and solve for y. And so if I do that based on my equation back up here, y equals negative cubed root of 0 plus 1 plus 2. 0 plus 1 is 1, so negative cubed root of 1 plus 2. The cubed root of 1 is 1, so we end up with negative 1 plus 2, and negative 1 plus 2 gives us 1. So my y-intercept is at 0, 1. So 0, 1. So I just didn't draw that great, but it should have been like that. Okay. All right, last problem. We have this function right here. And on this one, we can see that because there's a 2 in front, it either shrinks or enlarges based on that number. Some of you might have an idea of if it's shrinking or enlarging based on it being a whole number or a fraction. We'll go ahead and start with our key point. And on this one, my key point, our starting point, set that equal to 0. The x value will be negative 4, and the y value is at negative 1. So I'm going to mark that, negative 1, 2, 3, 4, negative 1. So that's our key point there. We know that for all cubed root functions, our domain is negative infinity to positive infinity, and our range is also negative infinity to positive infinity. Next, we'll find our x-intercept by plugging in 0 for y and solving for x. So 0, again, h of x is the same thing as y. 0 equals 2 cubed root of x plus 4 minus 1. In order to solve for x, I will add 1 to both sides. 1 equals 2 cubed root of x plus 4. We're trying to get the cubed root by itself. So you have a couple options, but I'm going to go ahead and just do it the same way as we did before. I'm going to divide by 2 to both sides. These cancel out. So I have 1/2 equals the cubed root of x plus 4. In order to get rid of the cubed root, we need to cube both sides. When I cube 1/2, I get 1 over 8. 2 cubed, 2 times 2 times 2 is 8. And then 1 times 1 times 1 is still 1. Equals, and when we cube a cube root, it eliminates our root, and we just have x plus 4. When you're solving here, you could eliminate your fractions first if you want to. So I'm going to go ahead and do that by multiplying everything by 8. When I do that, those cancel out. I have 1 equals 8x plus 32. In order to solve for x, I would subtract 32 next. 1 minus 32 is negative 31 equals 8x. And last, divide by 8. Negative 31 divided by 8 is negative 3.875. Okay? And so my x-intercept is at 0, negative 3.875. So negative 3.875, we're just going to put it right in there. So looking from my key point up, it went up 1 and then it's kind of in the middle. Okay, so it went up 1, right, like a half. Okay, so we're going to go down 1 and left like a half. I do not know where my y-intercept is right now. And now I know it's going to be somewhere up here. But just to be safe, we're going to go ahead and find what it is to just kind of make things more accurate on this one. And so y-intercept, we plug in 0 for x, solve for y. So I have y equals 2, and then the cubed root of, 0 plus 4 minus 1. And so we have 2 cubed root, 0 plus 4 is 4 minus 1. Now we're going to have to approximate this. If you have a calculator at home that looks similar to mine, in order to find the cubed root, you'll notice that your caret symbol here above this one, it has an x and a root. So that means you can take the root of any number. Well, since I want to take the cubed root, for my calculator, I first have to type 3, and then I do the second, and then the caret symbol, which gives me, see how it's having the x there with the root sign? And so that means it's taking 3 is actually going in the spot for x. And so that's the cubed root. And I'm just going to do a different number right now because we know the cubed root of 8 is 2, right? And so if I take the cubed root of 8, I should get the answer of 2. And so I'm going to do that and see how I got the answer of 2. So I know I'm plugging it into my calculator correctly. So at home, if you have a different calculator, you need to figure out, okay, I know that the cubed root of 8 is 2, and so play around with your calculator until you're able to get the correct answer. Okay, and so now, since I know how to find the cubed root, I'm going to take the cubed root of 4. Okay, so I'm going to clear that out. So for cubed root, I have to type in 3 first, and then I do my second, and then the one that has the x in the root, and 4. So the cubed root of 4 is approximately 1.587. I'm going to call that 1.59. And so if you're looking at this problem, this really is 2 times 1.59 minus 1. So you could leave this answer how it is in there. I'm just going to go ahead and clear it out and just go 2 times 1.59 equals that, and then subtract 1, and I get 2.18. So my y-intercept is about 0.2.18. So up here, 2.18, so we're going up 1, 2, and a little bit. Okay? And so this is curving up and over, and this is curving down and left. And so we have our cube root function graph. Okay? Working from left to right, you can see that this is increasing. This is asking where is it decreasing. So in this case, it is not decreasing. It is none. Okay? Average rate of change. Again, we know for average rate of change, we need to find the slope. We know our slope formula is y2 minus y1 over x2 minus x1. We need to have 2 ordered pairs. Right now, I only have 2 x values. So my x value is -3. We need to find the y value. My x value is 4. We need to find the y value. Okay, and so we're going to use that information and plug it in up here. So y equals 2 times the cubed root of -3 plus 4, and then minus 1. -3 plus 4 is 1, so the cubed root of 1 minus 1. We know that the cubed root of 1 is 1, so now I have 2 times 1 minus 1, and 2 minus 1 is 1. So this y value is 1. So one ordered pair is -3, 1. Okay, for the other ordered pair, we're plugging 4 into our equation. So y equals 2 times the cubed root of 4 plus 4 minus 1. We know that 4 plus 4 is 8, so 2 cubed root of 8 minus 1. We know the cubed root of 8 is 2, because 8 is 2 times 2 times 2. So then I end up with 2 times 2 minus 1. 2 times 2 is 4, and 4 minus 1 is 3. So this y value is 3. And then now we can plug that information into our slope formula in order to find the average rate of change. And so starting over here with the y's I'm subtracting, I have 3 minus 1 for the y's. And then since I started with 3, I start with 4, and I have 4 minus a -3. 2 negatives side by side make a positive. 3 minus 1 is 2, and 4 plus 3 is 7. So that average rate of change is 2, 7.